right, I decided to split this up into two videos, but we're graphing the logarithmic function, but these are using the natural log, okay, like you're going to encounter when you hit page 17 of your packet. All right, so what I did is I went ahead and did this example of what does the basic logarithmic function look like. And remember, I did that earlier on the other video where we did just a basic log function. Who cares what the base is, okay? The common log can be used for any base, okay? But the natural log is used for base e. And remember, e is a value, kind of like pi. We all accept the fact that pi is about 3.14. E is another value a lot like pi, and hopefully you will take more math or science courses and even business courses and learn the value of e. But what I want you to know is it's still a real number, and it's about 2.718. You have that button on your calculator, and let me show it to you. On my particular calculator, it should always be really close to your natural log. See, that's my natural log, and by the way, that's a letter L, not an I. Just like that's the LOG just spells log, this is an LN, lowercase, and it represents the natural log that always has base E. And you can see in green, right above it, I have got the little green E. So if I was going to use that, let me hit clear real quick on my calculator. Since it's in green, I'm going to have to hit my little green button. And look, I can see the E pop up. So if I want to know just what E is, and the way this is set up, I have to tell it E to the first. So look at my screen, E to the first, and I'm going to hit enter. And look, there it is. Okay, so that's the value of E. So anytime you see the natural log, you know it has base E. So they're not going to write that, okay? So remember I told you that I don't care what the base is, all logarithmic functions look like the little snake that's raising his ugly head right here. He's raising his little ugly head above the ground. He's right above that log. That's how we remember it. And he's hiding in the ground. Very, very scary. Okay, so this was with base 3. This one has base E. I want you to notice it looks just the same. You can see here it's still going through 1, 0. And so what I did is I just randomly picked some points, okay, and I plugged them into my calculator. That's a 10. All right, I just wanted to see what was happening. And if you were going to hit this in your calculator, it's so easy. But let me show you. Like if I'm going to do the natural log of 3.5, all I'm going to hit is my natural log and make sure it says LN 3.5, and I'm going to hit enter. And I mean, I'm graphing, so I'm just kind of I put 1.25, which you're going to see right here. So I just kind of did that so you could get an idea of what the graph looks like. And I don't want you to be stressed out whether this is an LOG, the common log, or an LN for the natural log. Who cares? They all look the same, all right? So when we do this example, since this is messing with my x, it messes with my mind. And the x goes back and forth, right? The x-axis. So you would think you would go right 3, but you don't. This tells me it's going to go left 3. Okay, so what I'm going to do is I'm going to take my basic function and move it left 3. It also, I still can never take the log of 0. I don't care if it's the natural or the common log. So I know x can't be -3. Okay, otherwise I'd get a 0. So my domain should be -3 to infinity. And your range is still going to be, did I say gonna? Your range is all real numbers. And your asymptote is going to be x equals, what can x not be? -3. Because that's what your asymptote is that imaginary line that your graph is going to get close to, okay, and never cross. So I'm going to switch colors here just for a second. I'm going to go back to this dude right here where my asymptote was the line x equals 0. And I just said, well, on this one, my graph is going to be x equals -3. My graph, my asymptote. So that's the line that's going to get really close. And what I'm going to do to this guy right here is I'm going to move him over 3. So take any point. This is the one I'm going to use. 1, 2, 3. So it's going to sit right there. Notice he's only 1 away from the asymptote. That's pretty common. And then it's going to raise its little ugly head. The only thing, and I know this is going to drop down and kind of hug the asymptote right there. I would like to know where he hits the y-axis. So how am I going to figure that out? Remember, to find the y-intercept, you always let x be 0. If x is 0, okay, so I'm going to put this in here. Whoops. This is for my x, this is for my y. Plug in a 0. I want the natural log of 3. Use your calculator. The natural log of 3 is 1.1. So that tells me where it's going to hit over here. So it's going to hit at just barely above the 1. So just a nice smooth curve. I missed him. And he just kind of goes up slow like that. So it should be an exact replica of this guy, just shifted over 3. Okay? So real quick, if I was going to do, what was the other one I was going to do? I think it was the natural log of x plus 3. Okay, notice it's not messing with my x. Okay, and by the way, you could also write this as 3 plus the natural log of x. So it's really not messing with this at all. It's just an add-on. This is going to make my graph go up 3. So my asymptote is still, I can't let x be 0. X can't be 0 because I can't take the log of 0. So my domain would be 0 to infinity. My range is always all real numbers. And my asymptote is what x can't be. So it would be x is 0. So take this graph, and I wish I could do it right here. We're still going to take this graph. My asymptote is still right here. And we're just going to take him and we're going to move him up 3. So let me see here. I think I have one more colored pen, believe it or not. I'm going to take this magic point of 1, 0, and I'm going to go up 3. 1, 2, 3. So I still have this. I know he's going to go up slightly, and then I'm going to come down and I'm going to hug that line. So they still look just the same. I just took my standard one and moved him up 3. So I think I usually typically make you plot 3 points. There's 1, and then just use your calculator and get 1 over in here or something. So you have a total of 3 points, but you should still know quickly what it looks like. And there you go.